This is Muhammad Arfan, and I am a PhD researcher at Swedish University. My research focuses on system analysis of renewable fuels from a life cycle assessment and life cycle costing perspectives. And today I'm going to talk about what is LCA. LCA stands for Life Cycle Assessment. The world is facing important environmental challenges such as greenhouse gas emissions that are considered responsible for increasing the Earth's temperature, industrial pollutions, and toxic emissions that are endangering ecosystems and clean water reserves, imported metals needed for electronics and machines are being scarce, fossil resources which society heavily depends on are rapidly depleting. To understand to what extent an industry, product, or process contribute to various environmental issues, life cycle assessment is one of the best tools to help with this. It is standardized methodology with a high degree of accuracy in results. This internationally recognized assessment tools helps to inform decision makers on product choice, allowing product engineers to reduce the negative impacts of new products on the environment, identify what can be improved in existing products, and avoid modifying one aspect that may cause more significant issues at another stage in the product life cycle. And even this tool allow to compare the environmental performance of similar products. So in the life cycle assessment, all stages of a product's life cycle are considered, such as resource extractions, material processing, transportation of the materials to the manufacturing plants, and then distribution of the products to the end users, and after the end of life cycle operations. These operations could be include reuse of the same product. These operations could be include reuse of the same product with some adjustment to the products, or recycling of the products completely or parts of the products, or maybe is partially sent to the landfill and partially to the incineration plant to create heat and electricity. How to perform life cycle assessment is standardized by the International Organization for Standardization. According to the standard, the impacts are measured and presented to an extensive set of environmental indicators. These are grouped into damage to human health, damage to ecosystem quality, and resource depletion. This way, products can be compared by using specific environmental themes. What are the environmental themes? We will talk about in the later lectures. However, this scheme allows us to answer questions like which product has the lowest impact on the climate change, or which product is the most toxic to human health, which environmental problems can be attributed to a certain product, what life cycle stages of a product are the most damaging to the environment, or where it is need to be focused to bring developments and improvements in the product from the environment and sustainability perspective. For example, in this example, there are two products, product A and product B. So according to the life cycle assessment results, here product B is much better from the environmental global warming potential point of view than the product A, whereas the product A is better from the human toxicity potential point of view. Similarly, the life cycle assessment allow us, or at least show us, which stages of the product life cycle are the most energy and resource consumption stage. So, for example, in this life cycle assessment results, we can see the manufacturing stage of of a product is has the highest impacts to the global warming potential in the global warming potential compared to two other stages, which is use and recycling. And life cycle inventory, if we go into more details, so we can further find what is in this manufacturing process contributing to the most environmental impacts. So, for example, in this case, it is highlighted that the resources or the plastic types of plastics used in this manufacturing of the product process are contributing most. For example, from this figure, we can see that PET is almost contributing 28% to this impact. PP is contributing 19%, and then some other materials that are contributing 27%. So, further going into deep analysis of this product manufacturing process, we can identify what is needed to bring improvements or at least to lower the environmental impacts of the manufacturing process of this product. For example, in this case, it could be replacing the some of the materials, especially PE, PET, with some other materials that are having lower environmental impacts, could improve the environmental performance of this product. LCA results can be used for marketing purposes, such as like eco-labeling is a way of communicating the product's life cycle environmental impacts from the energy point of view. So this is the categorization of the product from the energy consumption perspective. So if the product is labeled with A, means it is highly energy efficient from its life cycle perspective. Whereas if the product is labeled with F, which means it has a high energy demand throughout its life cycle operations. The LCA results can also be used for certification such as environmental product declaration, which is called EPD, and also for the product development, such as to identify which are the hotspots of the life cycle assessment of a product, which need to be tackled first in order to bring improvements to the product from its life cycle perspective. So in the next lecture, I will talk about life cycle assessment methodology. Thank you for watching.